For our final example in the exponential function section here, we have kind of an interesting notation that we need to talk about here. It says f of x equals negative, looks like it says negative 3 to the power x plus 5, which if you didn't know any better, you might think that that would mean that your b value is a negative 3. But I want to eliminate this for you a little bit here. What this actually means, this notation, the way they have it written, actually means a negative 1 times 3 to the power x plus 5. So that negative 1 is actually, that negative in front is actually a reflection over the x-axis. The notation is kind of weird, but the reason it can be written that way is because the order of operations says that the exponent takes precedence over the multiplication between the negative and the number that's there. So this would be equivalent to having parentheses around that, but the parentheses are considered not necessary. So you should expect to see things like that when these things are written. So our b value on this one, thinking about what it actually means there, would be a 3. So my parent function would be y equals 3 to the power x. Now let's go through all the transformations there. Okay, like we mentioned before, that negative 1 in the front is a reflection over the x-axis. The x is alone in the exponent, so that means there's no horizontal shift. There is a plus 5 on the end, so that 5 is going to be a vertical shift. And because it says plus, it's up. All right, so now for the horizontal asymptote. In the parent function, your horizontal asymptote is at y equals 0. And the horizontal asymptote would be changed based on vertical shift transformations. So since this one is shifted up 5, that means my horizontal asymptote is actually going to be at y equals 5. All right, so we'll sketch the graph of this one now. So I'm going to start with coordinate plane. And then I'm going to put in the horizontal asymptote. So that's at y equals 5, so that would be up here somewhere. And I'll put 5 by it, so that is labeled now. Then I'm going to do like I did before. So I'm going to start with the y-intercept from the parent function, and we'll do these transformations to it to find the new point. Light blue again. Okay, so if I reflect 0, 1 over the x-axis, that means that I'm multiplying the y value only by negative 1. So that would make it 0, negative 1. There we go. Okay, then if I move it up 5, it would add 5 to the y value in that point. So negative 1 plus 5 would be 4. So now that new point is going to be at 0, 4. So about right there. Okay, now from the parent function, this was a growth function. So that means toward the left, to the left of that y-intercept, that adjusted y-intercept, the graph is going to get closer to the horizontal asymptote there. And as I move to the right from that adjusted point, it's going to move away from that horizontal asymptote. So now if I look at my final graph there, I see that as I move from left to right on this graph, the trend is going downward. So the final result on this one is actually a decay function. So if it starts out as growth, but then it's reflected over the x-axis, that would change the trend and make it decay instead. All right, domain. Once again, the domain is completely unaffected by any transformations, so it's still all real numbers. The range, however, is going to be either everything above or everything below the horizontal asymptote. Taking a quick look at my graph there, looks like it's everything below that horizontal asymptote, so that would be y is less than 5. Now you do the rest of the examples, or sorry, the rest of the practice problems in this section.